Bristol Community College, Mathematics with Dan Avedikian, Math 131, Elements of College Mathematics, Section 2.1, Problem 14. This is number 14 from Section 2.1. Solve the system of linear equations 12x minus 5y equals 9 and 3x minus 8y equals negative 18. So what we need to do is make one of the variables have the same number in front but with opposite signs. So our options are 12x and negative 12x. That would work. Or if we want to cancel the y's, we could do negative 40y and positive 40y. Again, we should get the same answer either way. The x's seem like they'd be a little bit easier, so for that reason I'll cancel the x's, but you should be able to do either one. So if I'm going to cancel the x's, this 12x is fine the way it is. So I'm going to copy the top equation as is. 12x minus 5y equals 9. Now if I want the x's to cancel, the bottom equation right now has a 3x. I want it to be a negative 12x. So to make my negative 12x that I need, I'm going to have to do times not just 4, but times negative 4 in all of the equation, not just the x. So negative 4 times 3x is negative 12x. Negative 4 times negative 8y will be positive 32y. Right? Pay attention to your signs. The negative times the negative cancels, makes a positive. Same thing with the right-hand side of the equal sign value here. Negative 4 times negative 18 is positive 72. The negative times the negative cancels, makes a positive. So for step 1, one of my variables does have the same number in front but with opposite signs. I have a positive 12x and a negative 12x. Step 2 is add the equations together and cancel one of the variables. So 12x and negative 12x cancels. Negative 5y and positive 32y will be positive 27y. And now positive 9 and positive 72 will make an 81, positive 81 on the right-hand side of the equal sign. So that's step 2, add the equations together and cancel one of the variables. Step 3, solve for the remaining variable. So the 27y equals 81. I'm going to have y equals 81 divided by 27, and that does happen to come out to a positive whole number, a positive 3. Again, I can do that division in my head without my calculator, but if you have any hesitation at all, spend the 2 or 3 seconds it'll take to have your calculator tell you that 81 divided by 27 is 3. So that's step 3. I solve for the remaining variable. Step 4, take my answer from step 3 and plug it back into either of the original equations to solve for the other variable. You should get the same answer either way. The bottom equation has a little smaller value in front of the x, so for that reason I'll choose the bottom equation to plug my answer from step 3 back into. But you should get the same answer either way. So I'm going to start with 3x minus 8y equals negative 18. Take my value for y of 3 from step 3, and that'll be 3x minus 8y becomes 8 times 3 equals negative 18. And now 3x, negative 8 times 3 will be negative 24, and that's equal to negative 18. And now the negative 24 on the left has to be canceled, so I'm going to do plus 24 on the left side of the equals and also plus 24 on the right side of the equals. So on the left, I'm just going to have 3x, and on the right, negative 18 and positive 24 will be positive 6. And now divide out the 3 in front of the x. X equals 6 divided by 3 equals 2. So the solution to this system of linear equations is x equals 2 and y equals 3. Again, 2 for x, 3 for y should make both equations true both at the same time. Or if you want to think of it in terms of what the graph would look like, if you graph these two equations, the point at which they would intersect would have an x coordinate of positive 2 and a y coordinate of positive 3.